Hello everyone. Good afternoon. So today I am back continuing our learning with C programming language. Last time we left at learning about the header files. It was a very minimalistic approach which we took. So last time we tried to understand, for example, if we have some sort of function, or let me go back here. So last time what we discussed is we were trying to understand how simple programs work. So for example, in case in our program we had a function called add with tags. Now if we want our program to work, let's try to understand. If we want our program to work, then we have to declare this method add with tags and declare its body containing the implementation before the function where it is being called. So here it is called inside main function. What we have to do is we have to declare this function before main function. But as you can see, this is working fine. And why it was working fine? Because we used a because we use a header file, and inside that header file totaler.h we have only mentioned our declarations. So declaration will automatically make your code understand that what is the sort of declaration of the function we are going to use, and if the implementation is somewhere in the later sections of the code, the program will still work. So now today we will continue with our learning further, understanding what about header files and what about different sort of operations. So here is different things they have mentioned. For example, we have file header. For example, there is an encrypt message which basically simply exhausts the content of the message, and we have this encrypt message, and we want to use this encrypt message to encrypt a message. For example, we want to XOR it with 31, and we are XORing it, and it is totally fine. We want to call the encrypt function. We can call the encrypt function from our code directly. But what we want is, rather than calling this encrypt function again and again, or using this code of encrypt function again and again, what we can do, we can create a header file for that. So what we can do, we can split the code into separate files. There will be a one header file and other will be a message header file, and message header file wants to use file header file, let's assume, and it will import this header file, and the code will automatically will be available in this file rather than repeating the code again and again in each C file. So we will try to understand how the compilation works behind the scenes. So pre-processing fix the source. The first thing that the compiler needs to do is fix the source. It needs to add in any extra header file it's been told about using the hash include directory. For example, if we want to use in our example, like we wanted to use totaler.h, so here we will use hash include, and then we will mention the header file hash include directive. It might also need to expand or skim over some actions of the program. Once it's done, the source code will be ready for the actual compilation. It can do this with commands like hash define and hash iftf. So I'm not aware of what is hash iftf. We will learn about it later. First, I will just add some extra ingredients into the source. Compilation, translate into assembly. The C programming language probably seems pretty low level, but the truth is it is not low level enough for the computer to understand. The computer only really understands very low level machine code instructions, and the first step to generate machine code is to convert C source code into assembly language like this. So this is an assembly language code. I'm not aware of that one also. So if you want to understand assembly language, you can go over the internet, and I think there is a channel called Live Overflow. Yes, Live Overflow, and you can watch his channel, and there are amazing content on assembly language. Looks like pretty obscure. Assembly language describes the individual instructions that the central processor will have to follow while running the program. So it is the basic processor they are trying to make us understand the basic process of compilation. So first the code is compiled and the source code is being converted into an assembly language. The C compiler has a whole set of recipes for each different parts of the C language. Those recipes will tell the compiler how to convert an if statement or a function into a sequence of assembly language instructions. But even assembly isn't low enough for computer. That's why it needs what? Assembly generate the object code. That's why it needs the, I don't know, nothing mentioned. So the compiler will need to assemble the symbol codes into machine or object code. Okay, okay. This is the actual binary code that will be executed. Okay. So assembly generate the object code. After all, you have taken the original C source code and converted into zeros and ones of the computer circuit. So assembly is even gets converted into the machine code. But no, there is still one more step. If you give the computer several files to compile for a program, the compiler will generate a piece of object code for each source file. But in order for these separate object files to form a single executable program, one or more thing has to occur. Now the linking. So these are steps how it is performing. First is pre-processing, then it is compilation, then it is assembly, and then it is linking. So in pre-processing, it will try to understand, bring all the files into a single sort of box where it will push all the ingredients of a file. Then it will compile, convert the source code into a assembly language. Then it will assembly basically converts the assembly instructions into a object code, which is binary 0 or 1 machine code linking. Then once we have all the separate pieces of object code, we need to fit them together like jigsaw puzzle to form an executable program. Then executable is generated. The compiler will connect the code in one piece of object code that calls a function in another piece of object code. Linking will also make sure that program is able to call library code properly. Finally, the program will be written out into executable program file using the file format that is supported by the operating system. So this is very important because when we try to compile a code on the Linux machine, the binary which is getting generated is compatible with only the Linux machine. But when we try to compile the code in the Windows machine, the binary will get created in an exe format because that is being compatible a Windows machine. So this is also the job of the compiler to generate the executable program file format in a file format that is being supported by the operating system. Okay, and different currently today's programming language like Go programming language has this power to generate binary in different that supports a different underlying architecture. For example, even if you are working on AMD 64 architecture, you can generate binaries for ARM 64 architecture using different flags in the Go programming language. I'm not sure about is it possible in C or not. So how do you actually tell the GCC that we want to make one executable program for several separate source files? Let's try to understand. So we will use a hash include encrypt.h file, which we did earlier also. Include encrypt.h in your program. Tell other programs about the encrypt function. So let's try it out. So we will inside a you will include the header inside encrypt.c. We will create okay, so inside we will create a function, then we will call that function. Okay, okay, good. So what we will do is we'll use hash include um, in encrypt.h, and here we will create a function encrypt, and that takes a pointer to a character, basically that is a string, and then do we have to return something? No, we are not returning something. Then what is the purpose? We are taking a pointer, so it will automatically get converted. Sorry, I apologize. So then we are encrypting it, and what we have to do is we have to take one character, and then we will take a c equal to message, and then while value at c is not equal to sentinel character, we will keep on writing the continuing, and the value at each message must be equal to value at message and being XORed with 31, and then we will do C++. No such file or directory, so it told us to hash encrypt.h encrypt.h. So we will write this here, and then in our hello.c, what we will do, we'll use hash include in encrypt.h, and here we will also call. Now we will create a message. So we have created a message, and then in encrypt we will pass message to encrypt function, and then we will print. So I think I have done something. Now I will paste the encrypt.h. Sorry. Now let's see what will happen when we will try to run this code. So we have done it, but we have to understand how we are going to build our code. Okay. So here it has taken the content from the input, but we are not doing that. So it is encrypting the file. Simple message hider.c encrypt.c -o message hider. So we are compiling both the files. So we are compiling both the files gcc encrypt.c and then hello.c into oh, no such file or directory encrypt.h. The header inside encrypt.c. Okay, so got it. So we have also to define the uh, okay. So this was a mistake. What we have to do is we have to create a header file. We have to create a header file also. Just like totaler.h, we can add a header file in encrypt.h. Okay, and this encrypt.h, we just have to mention the function parameters. So we avoid encrypt, and it takes a character pointed to a message. That is the only definition. Now now it is see, now there is no error, and in hello.c there is no error. So now we can go and build our code. Yes, and now if we call h, hello, how are you? There's something wrong with the program. H has been encrypted, but others are not. So we will look at our encrypt.c function. Oh, sorry, my mistake. So what I have done is I have message. Message is a starting address basically. So what I can do here is value at message is not equal to sentinel character. I will increment the address by 1. Hmm. Now the message has been encrypted properly. Okay. So what we have to do, we have to create a header file, and in that header file we will only mention the function declaration. Function definition, sorry. In the function here, it will be the function definition and function definition. And during compilation of the program, we don't have to mention the header file. It will automatically try to detect where the header file is present, and depending upon the path we have mentioned in the hash include. So inside the normal C file, we will write our implementation, and then another C file where we want to use it, we will call it and we can use it. Okay, seems good. Now let's move further. Every time I make a simple change in one file, it takes an age to recompile, and I am working on a schedule. Okay, so it is taking time. Breaking your program out into separate source files not only means that you can share code between different programs, but it also means that you can start to create really large programs. Well, because you can start to break your program into smaller self-contained pieces of code. Rather than being forced to one huge source file, you can have a lot of simpler files that are easier to understand and maintain. Absolutely correct. So one plus side is that you can start create really large programs. The downside is you can create really large programs. C compilers are really efficient pieces of software. They take your software through some very complex transformation. They can modify your source like links of 100 files together without blowing your memory, and even optimize the code you wrote along the way quickly. And even though they do all that, they still manage to run quickly. But if you create programs that use more than a few lines, the time it takes to compile the code, obviously it will start to increase the time which our compiler takes to compile the program. Let's say it takes a minute to compile a large project. This might not sound like a lot of time, but it's more long enough to break your train of thought. If you try out a change a single line of code, you want to see the result of that change as quickly as possible. So we don't want to wait for a long, huge amount of time when we are working on some bug or fixing some sort of code. We want to quickly change it and saw the result. What is the result being generated? And there, if compiler is taking a huge amount of time to build our code into a binary, then we have a difficult task. You have made just a change in one or two source code files, but we have to build all of the files from the scratch. It will run the preprocessor, compiler, assembly, and linker for each source file, even the ones that haven't changed. So this is a very hectic task, a time-consuming task. If you tell the compiler to save the object code it generates into a file, it shouldn't need to recreate it unless the source code changes. If a file does change, you can recreate the object for that one file and then the whole set of object files to the compiler. They can be linked. Okay. So if you change a single file, you will have to recreate object file from it, but you won't need to create an object code from any other file. Then you can pass all the object code files to the linker and create a new version program. So this is an amazing task. He's saying that rather than building the object code file for each and every C source file, the compiler can do is save the state of the each object file, and if there is a change in the source file, then only change the object file of that specific source file and then send all the code file to the linker, and linker will create an executable. So how do you tell GCC to save the object code in a file and then get the compiler to link the object files together? First, compile the source code into object files. You want object files for each of the source file, and you can do that by typing this command. So what we can do here is let's remove the binary. So we can use gcc dash c for all the C files, encrypt.o, hello.o. So the object files are being created. So these are the object files which are being created. So object file of each file is getting created. Then we can link them together. So we will use gcc dash star.o and dash o h. Now the h will also return the same output. Amazing. So we are creating object files. Now if there is a change only in encrypt.c, so for example, rather than 31, I want to do it by 32. What I have to do is gcc dash c encrypt.c. I will compile it, then an object file is generated. So what I am going to do, gcc star.o and star.o, and I'm going to generate output as h1. And if I run h and if I run h1, the output is different. Okay, so this is amazing. And rather than I am going to gcc, then mentioning hello.c, then mentioning encrypt.c, and then outputting the same file to the h1. So this is much more time consuming than that. Change it back to 31 from encrypt.c. Okay, this is an amazing thing. So the compiler is smart enough to recognize the files as object files rather than source files. So it will skip the compilation step and just link them together into an executable program called launch. This is very important. It is used to convert the object file. So I have been using this at the beginning. Rather than first creating the object files and then linking them together, I was directly running a command that directly generates a binary. Now we have been using it to its full potential. gcc-c compile. So source file gcc-c converts source file into object files, and gcc-o converts links the object files into an executable. Amazing. Two files and then okay, nice. So yes, now they were showing some sort of demo and we skipped that. It's true, partial compiles are faster, but you have to think of make more carefully to make sure you recompile everything you need. That's also true because we are not sure. We have to think about it in our mind that what changes we have made to which files, and only those files need to be recompiled. Other files need not to be touched. So we have to keep this in mind. I thought the whole point of was saving time. Now I have to get distracted. Now the compile is faster, but I have to think a lot harder about the file which we have to change. If you are working on just one source file, things will be pretty simple, but you have changed because you have changed a few lines. It's pretty easy to forget to recompile some of them. That means the newly compiled program won't pick all the changes you made. Now, of course, when you come to ship the final program, you can make sure you can do a full recompile of every file, but you don't want to do that while you are still developing the code, even though it's a fairly a mechanical process to look for files. So is there something way we can use to automate the process? Wouldn't it be dream if there is a tool that could be automatically recompile the source code that's changed, but I know it's just a fantasy. Make tool. So you can compile your application really quickly in GCC as long as you keep track of which files have changed. That's a tricky thing to do, but it's a pretty straightforward to automate. Imagine you have a file that is generated from some other file. Let's say it's an object file that is compiled from a source file. How do you tell thruster.o file needs to be recompiled? You just look at the timestamps of the two files. If the thruster.o file is older than thruster.c, then the thruster.o files need to be recreated, otherwise it is up to date. And this is a pretty simple rule. And if you have simple rule for something, then don't think about it, automate it. Make, now we will use make tool to do that. Make is a tool that can run compile commands for you. The make tool will check the timestamps of the source files and the generated object files, and then it will only recompile the files that have gotten out of date. But before you can do all these things, you need to tell make about your source code. It needs to know the details of which files depend on which file, and it also needs to be told exactly how do you want to build the code. Every file that makes is compiled is called a target. So our C files will be called as target because they are getting compiled. Strictly speaking, make isn't limited to compiling files. A target file is any file that is generated from some other files. So a target file might be zip archive that is generated from a set of files that needs to be compressed. So make is independent of only creating object file, it can do anything. For every target, make needs to be told two things: the dependencies and the recipe. And the dependency means which files the target is going to be generated from, the set of instructions it needs to run to generate the file. Pretty simple. So what files we are going to use that the target needs to be generated from. In our case, it was encrypt.c and hello.c, and the recipe, the set of instructions we want to make it perform. So yes, so the steps which we wanted to perform is gcc-e thruster.c to generate uh, a simple object code, and then gcc start-auto-o launch to generate a linked binary. Also, if you are working on Windows, it has been mentioned that you have to use a make version called MingW32 make, and Microsoft produced their own version called nmake if you want to use that if you are working on a Windows operating system. Tell make about your code with the make file. So how we are going to do it? We have now a launch file and we are going to create launch.o, thruster.o, that is compile thruster.h and thruster.c, and we are going to do it with the help of make. Launch.o gcc-c launch.c gcc-c thruster.c, then we are going to use gcc launch.o thruster.o to launch. Okay, the recipe must begin with a tab character. Okay, so let's try to write our make file, and I think make is present on my system. Make is present on my system. So what we can do is we can create a make file, and inside make file what they are trying to do is, sorry, this is target. So launch.o, this is target, and here launch.c dependencies, these are dependency. Launch.c launch, oh sorry, my mistake, we are using encrypt.o, and for encrypt.o we use encrypt.c and encrypt.h. Okay, and then obviously a tab and the command which we are going to run, gcc dash c compile our encrypt.c. Okay, this is fine. Then we will generate hello.o, and hello.c we will use hello.c and sorry, encrypt.h, and here we will use gcc-c encrypt.o recipe. Then we will create a binary h, which is a target, and we will use hello.o, and we will use, sorry, first we will use encrypt.o, and then we will use hello.o, and here we will use gcc encrypt.o, yeah, encrypt.o and hello.o, and dash output will be h. Then let's see what will happen. Ls rmh, so if I'm going to run dash h, okay, then rmh encrypt.o and hello.o. Now we will run make. What? Oh, make launch. Oh, I only mentioned make, So once again, let me delete these again. So encrypt.c, okay, make, and I have to mention the target. In make file, I have to mention make and h. Cannot find hello.o. Sorry, my mistake. What I'm gcc encrypt.c encrypt dot. Okay, sorry. Let's see rather than hello.c rm encrypt.o make h. Now dot slash h. It is working absolutely fine. So it performed all the three steps. So let's do one thing. Mm, cat make mm, cat make file, and we are going to rm encrypt.o and h and hello.o. Sorry, oh, we are going to remove it, and then we will going to make and only the step which we want to execute till hello.o. So if we do ls, only hello.o is being generated. Okay, because also the dependencies we have to mention. Why when we executed h, both these steps got executed? Because it has the dependency on both encrypt.o and hello.o step, encrypt.o and hello.o step. So this is the target which is being generated, and these are the dependencies. So here the dependencies on encrypt.o and hello.o, and that's why those two steps also get executed. Nice. So and we already performed it. Okay. Now there is a lab, and I am not aware of this lab. It seems like it's something to do with the Arduino. I don't have Arduino, but see, let's see what is it. This lab gives you a specific spec that describes a program for you to build using the knowledge you have gained over the last few chapters. This project is bigger than the ones you have been so far. So read the whole thing before you get started and give yourself a little time. There are no new concepts here. We can do it. Okay, so it is amazing. If you want to do it, uh, you you definitely should. The moisture sensor detector, we have to use Arduino. We can use LED lights, Arduino, breadboard. Seems like an amazing project. C code is also there. They are different. Also, the functions embedded C programming language also mentioned there. You can also use that. You can also use those functions, but um, currently I don't want to spend time on it. So rather than going to this lab, we can move ahead currently and try start with the structures. Okay. So then, if later on, if we have time, we will definitely go back to it and try to understand how it works. So rollover. So now we are going to understand about data structures. Data structures is like if you have used other programming languages like Java or Python, there is dictionary, there is classes in Python. So in rather than the classes, because classes are later introduced like object-oriented programming concepts, C does not have this concept. So C uses structures. That those are called structs, and it defines a simplistic structure of any data we want to use. For example, let's move forward. Let's try to understand how they have made us understood about it. So you have seen that C can handle a lot of different types of data. Small numbers, large number, floating point character, text. But quite often when you are recording data about something in the real world, you will find that you need to use more than one piece of data. Take a look at this example here. You are using two functions. Both need the same set of data because they are both dealing with the same real world thing. Catalog, the name, the species, teeth and age. Name, species, teeth and age. So what we can do here is, we rather than passing each and every variable differently, we can create a structure of fish that will contain all the data inside it. So struct fish snappy equal to snappy piranha 694. So we can create a structure like this. Okay, so here what we can do is, we can create our function. Inside our function, not inside our function, but outside our function, we can create a struct. Sorry, spelling is incorrect. Fish, and for that we can define, for example, character constant pointer, character pointer, and name constant character pointer, species, and then integer t, and the last one was integer age. So this is the structure, how we define a structure. And now we want to create a snappy. So how do we define it? Struct, just like similar to character, struct which fish, and the name of the variable equal to, and we define it with like this bracket. So first is snappy, second is name of species, Anna, and then third is 69. So this will create our structure. Okay, bracket semicolon. That's something correct. Oh, okay, okay. Here also. Now it is fine. Okay. A constant character pointer is your first string that you don't want to change. We knew that. The structure in the, okay, so the store the string. The structure here just stores a pointer to a string. That means it's just recording an address, and if we want to iterate over the address, we can get it. Now, for example, how we are going to use some functions on that specific. So, for example, void catalog and void label. Now we are, rather than declaring all the variables inside that function, we are directly going use struct fish and catalog and label. Okay, and we are going to print something. Happy 0. Okay, okay. Because the structure structs like a little array, you might think you can read fields of an array like this. No, it will not work. I know it. So how we are going to access it? With the point. Yes. So we will create a function above it, int print name, and it will take a struct fish f, and for that fish we will do puts f dot name. We will pass the, sorry, fish fish. We will print pass the fish here. Sorry, not fish, snappy. Okay, and what it is showing? It is showing implicit declaration of puts is not available. Hash include stdio.h. And now what we can do, gcp dash gcp structs.c dash os permission denied. gcp struct.c dash o sorry. So this C was only used to generate the object files. So and it works because we were able to access the name, and name is a pointer to a character, and it's a pointer to a character. That means if we print the first address, it will automatically print the whole string. So it works totally fine. So this is understood. So we can move forward. Whatever you want to print, you can print it out in on your own way. So it's struct like just like an array. No, but it's a group of data, sort of group of data that holds together. You can only access fields by name. We can't access it like 0, 1 or something. A struct variable is a name for a struct itself, so it is also a keyword, reserved keyword. So it is written that all structs are like classes in other language. They are similar, but it's not easy to add methods to structs. In classes, we can add methods to them, but it's not the similar thing for structures. So, but what when you define a new variable, the computer will need to create some space in memory for an instance of the struct. That space in memory will need to be big enough to contain all of the fields within the struct. That's true. So the assignment. So they are trying to make us understand something about the assignment. The assignment copies pointers to strings and not the strings themselves. That's true. We understood that. So when you assign one struct to another struct, the contents of the structs will be copied. But if as here that includes pointers, the assignment will just copy the pointer values. That means the name and species field of national and snappy both point to the same string. So here what we are trying to do is national and snappy. So what it is doing, so name species. Okay, so what we did is we point national to snappy. So what do you think will happen when you assign a struct to another variable? Well, the computer will create a brand new copy of the struct. This means it needs to allocate another piece of memory of the same size and then copy over each of the fields. But the pointers, remember when you are assigning struct variables, you are telling the compiler to copy the data. Okay, okay. The name is, everything else will remain the same. We will only change the name of that. Yes, the same strings. Both point to the same strings. So we can see both are pointing to the same strings. Okay. Can you put one structure inside an instructor? Remember that when you define a struct, you are actually creating a new data type. It gives us a lot of built-in data types, but a struct lets us combine existing types into a together. So we can embed one structure into another structure. So we have created a preference structure here, and we are embedding fish preference structure into fish structure. So let us try first this. What is basically happening here? So what we have done is we have print fish snappy. Then we will create new structure fish and gnawer equal to fish. Okay, and then what we will do is we will print the name. Undeclared first use in this function. Oh my god, happy. So now we will try and build it again. Snappy. That is absolutely fine. Now what we are going to do is gnawer dot. We will update its name equal to gnawer, and then we will see what will happen if we are going to print the name now. So first it was snappy. You have just updated the name of the snappy and the name of the GNAWER gets changed. So we have to understand that whenever we are copying the data, the only thing that all the so it is mentioned here that it means that the assignment will just copy the pointer values. This means that name and species filter Navar and Snappy both points to the same string, but the brand new copy of the structure is getting created. So even if we update the name of that, so what we did is we updated the name of the GNAWER. Snappy will not get impacted. Only the new name which we have updated will get impacted. Okay. So it is also clear that we can embed one structure into another, and we can create it like this. Create another structure inside one structure, and we can call it with the help of dot dot dot. Pretty much clear. So it is very simple points to remember. Okay. Now let's move on further. When you create a variables for built-in data types, you can use simple short names like int or double. But so far, every time you have created a variable containing a struct type, you have to include struct keyword. That is exactly correct. So whenever we are creating a variable for it, we have to properly give struct keyword, struct fish, struct fish. Okay, but we don't want to do that. I think that is where typedef keyword is used, what they have mentioned. Okay, struct cell phone int cell phone number, constant character pointer to wallpaper, float minutes of charge, struct cell phone C equal to this. But C allows you to create an alias for any structure that you create. If you add the word typedef before the struct keyword and a name, and type a name after closing the braces. Typedef, struct cell phone, and then phone. Amazing. So typedef, and here we will mention fish. Okay. Now rather than using, it will also work. Amazing. This is a very amazing thing we can do. So we don't have to write struct fish, struct fish, struct fish, struct cell phone everywhere. Okay, nice. This is amazing. Now how do you update a struct? Okay, so this is what we did. This is what we tried. We used dot method and we updated it. So this means if you look at this piece of code, you should be able to work out what it does, right? Let's try to look it out. So it is creating a structure, but it has not assigned a name here. So it has used a type def turtle, and it is string with name, constant that cannot be changed, species that cannot be changed. Okay, age seems like string t dot age equal to age plus 1. Printf, so we will go to main turtle. We are creating a turtle. This goes to name, this goes to species, and this goes to age. Happy birthday turtle. Age is being increased by 1, but the problem here, once again, we try to understand, it will not increase the age by 1 because we are passing the copy, not the address. We are passing the turtle here, and turtle, it will increment the age here of the copied data, and then this will not increase the age. What it is trying to say is, if we try to create a method void increase age, and we are going to pass here fish f and f dot, oh my god, f dot age equal to f dot age plus 1. Okay, this is the only thing it is saying, that we are increasing the age by 1. And then at the last, what we can do is we can call this method, sorry, 1 second, I don't know what happened. Sorry for the delay, because I think was now let me come back. Yes, so I'm back. So what we were doing is we were increasing the age of the fish by one. So and when we now what we will do, we will cause increase age by and pass snappy snappy, and then we will uh, print the age of printf age of snappy is %d backslash n comma snappy dot age. And if we call it even before, yes, so we can see here that what we are doing here, we are printing the age, then passing it to the increase age function, and then increasing the age by one, but it increases the age of the copy, not the exact snappy we are using here. So if we run it here, gcc, what was the name, structs.c dash os, and then we execute it. So age of snappy is still 4, age of snappy is still 4, because it is so obvious. So now we will see how can we pass the function. And if we want to pass the function, so what we can do here is we can obviously pass the address of this structure, and here rather than holding the direct, we will see it will hold the pointer. The problem is here, and I think what I remember as per my old memory, we will use this greater than sign, this sorry arrow sign to refer if we are using pointer. So now let's try to run this code. See, now the age has been increased by 1. So if you are referring to a variable direct from the object, then you can use dot. But if you are referring it from a pointer to an object, then you have to use arrow syntax. So let's see it out what they have done. So turtle, hold the pointer to a turtle, and in order to refer it, if t is a pointer to a turtle, then the age of the turtle be pointer to turtle value dot age is not equal to pointer to age. Oh, they have used something else. They have used something else. So what they are trying to refer is star before a variable name. So let's see whether it works or not. But so they are saying that if we are going to use, we are going to value at f dot age equal to value dot f dot age plus 1. So this also works. Those also works. This also works. So we, now t is not a now a pointer variable. T versus pointer to t versus age versus pointer to t dot age. So pointer to t dot age will first resolve the uh, pointer, then gets the value at it. So rather than doing this thing for t, we can do this thing for the name. Yes. So this will help us to understand. So let's try to get the pointer here. Oh, don't, let's not change it. Put f dot name is fine, brother. So print species. Let's create a new function, print species, and inside that we will pass fish, but which is a pointer to f. And now, so uh, so the first thing they are saying that if we want the exact uh, we want to refer to the species, so how can we refer to species now? So if we want to refer directly, we can refer to f dot species, but currently it is a pointer. So they are saying that rather than referring to the species directly, we have to first get the value at that specific address and then put it in puts. Okay, So if I go here and I'm going to call print species of snappy, and what it will print. Sorry, my mistake. Pass the address, then execute. So piranha was a species. It is fine. But what will happen if I do pointer to f dot species? So if we try to understand the value of f dot species, it will not work. It will not work. So we can do print f percent s dot species. It is not working. So what they are trying to tell us that percent %t was wrapped in parentheses. It's because two different expression. This is very different, and the content of the memory location given by t dot h, that is exactly what they are trying to say. So it is the contents of the memory location. So basically f dot species give us a memory location because it is a pointer to a character. Definitely it's a pointer. So it contains see, it is not working, I think. Dot species, if we are going to use this, it will print the same thing. It prints the memory. Okay. So it is a very different. Oh, because we use the printf. Yeah, obviously that's why it prints the memory. So if we use it inside puts, it will also print the same thing. F species. Yeah. So what we have to understand, I'm not sure about what is this, but it understands that value at t dot a. T dot a, if it gives some sort of memory address, then it will try to get the value at that specific memory address. But this what it does is first it was t, then it gets the value at that specific address, and then it gets the age of that specific variable. These two meant the same. This is what we did. A little age increased. It was amazing. Why isn't it? Because the computer evaluates the dot operator before it evaluates the star operator. So first the dot value is dot variable is evaluated, and then okay, amazing. Save it at chapter sorry, it at dot text chapter 3 txt chapter 3 slash chapter 8 file, and dot slash chapter 4 encrypt dot chapter 4 encrypt dot h slash chapter 1 dot c and dot slash status. So git restore dash 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 s binary. So only text file, make file, h file, hello file, and zip file. So we will git commit dash commit chapter. So started chapter 5. Okay, that's fine. Now we will push it later. Okay. So now let's continue. Sometimes the same type of things needs different types of data. Okay. So type def struct short count float weight float volume, and we are using fruit. That's fine. It will take up space in memory. Sometimes someone might set more than one value. There is nothing called quantity. It would be really useful if you could specify something called quantity in data type and then decide for each particular piece of data whether you are going to record a count, weight, or something else. In C, you can just do that by using a union. Okay. So a union lets you reuse memory space. Every time you create an instance of struct, the computer will lay out the fields in memory one after the other. Exactly. So this is first memory allocation will be first section of memory will be allocated to the first variable inside the structure, second, then third, and this will keep on increasing. This is space for integer, this is space for weight, this is space for name. Okay, so we try to understand. If we try to understand something, let me open structs.c. So if we create a pointer to a structure, fish pointer to fish, fp equal to address of stgnawer. Okay, and what we are going to do here is the pointer, and which we have been using in the above code also, here also, and we were referring to it as arrow key if you want to refer to some of the variables. But what does this first piece of memory contains? If we try to understand, so the starting section of the code block, the it is saying the starting section of the code block contains the name. So if we want to print name, okay, name, we are passing puts f dot name. What is the puts take one argument and it is incompatible. Yeah, definitely it is incompatible because it is a pointer to a structure, not a pointer to a character, but it is a pointer. Hmm. So what we can do here is, okay, so let's try to try to print the address. Printf address of snappy is %p backslash n comma address of snappy. Okay, and the address of snappy name is address of snappy dot name. Fine, let's try to run this code. So if we see, both are the addresses are absolutely same, totally same. That's what they were trying to say, that the structure address starts from the first variable of it. If you can see, the address is absolutely same, and we can create a pointer to a character. What I want to do here is, so it is f dot name, and if I'm, what it needs is a basically a pointer to a so let me create a character pointer n, and if I pass it n, it will work. But the point here is n is uninitialized. So if I want to initialize an n, what I can do here is I can convert it into a character pointer and take the address of f. Will it work? So we have to understand now. So what it does, it takes the address of f, okay, and tries to convert into a pointer to a character. The address was same, and then it gets converted into a character of a pointer, and then take the first address of that specific variable, which is similar to the name, where the name starts, and then we will try to run this code. Nothing happens. Very bad. Very bad. Okay, maybe these sort of things does not happen, but what we understand is the address location was exactly same. If we try to print the address, printf address of Snappy. Yeah, this was exactly same. Every time we run the program, this will always be same. A union is different. A union will use space for just one of the fields in the definition. So if you have a union called quantity with fields called count, weight, and volume, the computer will give the union enough space for its largest field and then leave it up to you which value you will store in there. Whether you set the count, weight, or volume field, the data will go in the same space in the memory. Okay, we are not going to use union anywhere. We often use with structs. And how to define, by the way, union? How do you use a union? First field. Then you can use C89 notation to give the value for its first field. Short, float, weight. A union looks like a but it uses the union keyword. So typed as struct, another struct, we have to mention typed as union. Okay, okay, let's move on further forward. Not a big fan of union. Okay, enum, the most important thing which I really like about different programming languages. So sometimes you don't want to store a number or piece of text. Instead, you only want to store something from a list of symbols. For example, days, Monday, Tuesday, Wednesday, months, or some enum values. That's why enum were invented. So enum colors red, green. Okay. So let's assume the species we are going to use. Species here is not a type of struct, a type of constant string. So we can do, or we can create some new parameter for it. And let's say enum color. Enum color, colors. So color is red, comma, green is. So we created different colors for enum, and then we can, any variable that is defined with enum colors can store that specific value. Under the covers, the computer will just assign to each of this symbol in your list, and enum will just store a number. Only a number is assigned. For example, if we are using a red, it will get assigned 0. Green, it will get assigned 1. Boost, it will get assigned 1. But you don't need to worry about what numbers are in the sequence. You can just refer to the symbols and it will try to understand. So here, order contain order dot units equal to prints, order dot volume dot order name. Fine. Enum test. So we can create any. So let's try to create an example. So we will create our enum uh, species color equal to we can use that. Okay, so we can use color as colors enum. Okay, and then while assigning here we can assign it colors dot red. So colors, how to use it? Sorry, my bad. Type def enum, but it mentioned that you can create possible colors in your enum. Favorite equal to boost enum colors color. Okay, okay, okay. So you can only use red. Oh my god. So directly use red here. Type def count more, or we can use it like this also. It is totally dependent on us. How do we want to use it? And then if we want to put color, sorry, printf color of snappy is percent. How we are going to print it? I'm not sure. Percent d. if. So we can use conditions like if snappy dot color is equal to red, then put yes, snappy is red. This is the better approach. Statement with no effect. Why is it with no effect? So how we are going to access enum, unit of measures, units, root order, root order, uh, root order, order, and order dot units equal to point. Oh my god, I'm right. Order dot units equal to points. Why this is showing error? Snappy. Oh my god. Yes, now it work, and now we will run it, and it is snappy Z. So it is fine. And what it prints, we can also check that. Printf percent s backslash n, and here we will go snappy dot color. See, hmm, it is saying it is not a water type. So I think it is percent d. Percent. Yes, it is percent d. 0. So red is 0, green is 1, and yellow is 2. So it is fine. Now I think it is more than enough for today. Now we will go to, I think there is a bit manipulation or something related to bit fields. Yes, now we will go into that later. So we understood what are structs. We understood how can we address the addresses of structs. How can we address, we are passing the address, how we can use that. We did not go with the unions because I have never seen anyone using unions. I'm not sure about it. If you want, you can read it over the internet. And the third thing which we tried to understand about was related to the enums. So this was our whole session today, and I hope you are learning a lot. So thank you everyone.